Yeah, hello and welcome to our lecture series on climate protection. So there's only one lecture upcoming, and today our guest is Rene Schwaiger. Rene Schwaiger is a postdoctoral researcher at the Department of Banking and Finance. His research interest is in experimental environmental economics as well as experimental finance. In both cases, he works with controlled experiments to investigate how individuals, groups, and the market behaves. Rene Schwaiger is the scientific coordinator of a lab operations at the University of Innsbruck EconLab. Moreover, he gives courses for professionals as well as graduate and undergraduate students. So what's the topic of today? It's carbon pricing. As last time, if you remember our last lecture from Julian Bender in April, so it's some weeks ago, it was also on the topic of carbon pricing and is a powerful instrument for climate protection, if it's well understood and accepted. Today, Rene Schwaiger, he will also talk about carbon pricing. His talk today is about crowd science project called Many Designs Carbons. This project is a research project about the impact of behavior interventions on real-world support for a price of carbon. Yeah, welcome, Rene Schwaiger.
Great. Thanks, Rainer, for the introduction. Thanks so much for having me today. So it's a pleasure to present this large-scale project on which we worked on for over 2 years now. So it's about meta science, crowd science, and the main question on how we can implement effective and efficient policy instruments to circumvent climate change. Okay, this is what all this is about. The project is called Many Designs Carbon, and we asked the question whether behavioral interventions, so social science interventions, can actually increase support of people for carbon pricing. This is the main focus. So let me give you some outline of my presentation. First of all, I'd like to motivate a bit what all this is about and give also a focus of our main research, talk about the methodology. It's crowd science, meta science, and then we go into the procedures, talk about the results, which analysis we're going to do now as well on top of all what we did, and then finally I'm going to conclude. Okay, before I start with the actual project, I'd like to give you some context. I think every one of you who is here is familiar with that, but just to give you some introduction on what this is about and why also social scientists are very interested in climate change, because it's a very severe problem. What I brought with me is some evidence from the IPCC reports, multiple of them. I used the 2022 one here. What you can see is that on the right-hand side, a graph that reconstructed actual temperatures of the last 2,000 years. And what we see is that in the last century, the last decades, the global temperature increased massively, which is completely unprecedented, right? And there are some measures of scientists to come up with that. You can look at trees, you can look at glaciers to reconstruct temperatures. Also, some people would argue that these are natural variations that lead to this temperature increase, but this doesn't add up. What you see on the right-hand side is a graph that simulates how the temperature would look like if you only looked at natural factors, natural variations, for instance, the sun. This does not explain the vast increase in the last decades, last century. But if we add to the natural variation also the human influence, this perfectly correlates with the actual temperature increase we saw. So there is a very strong evidence, very strong case that this is actually true, and then the human caused, more or less. This is the main idea. Also, when you look at the CO2 concentration in the atmosphere increased massively. How do we know that? When we look back 800,000 years, how can we know that? Actually, glacier ice. Because if you dig deeper down, you have some layers where you can measure the parts per million of CO2, and then you can infer how strong the concentration was in the past. And now it's actually the highest in 800,000 years. So this also adds up. This correlates strongly with temperature increase. Okay? So I think I don't have to motivate why this is important. We have several negative consequences which we have to circumvent. Extreme weather events, we have the sea level rises, which can flood cities and be a massive problem. We have glaciers melting, and we have also the problem that, for instance, mass migration in countries and regions where it's definitely too hot to live will be also an issue for Europe and Western countries. So we need to circumvent that and curb climate change most effectively. And social science also tries to add to the puzzle, to the solution puzzle here. An inconvenient truth is that we as households are not innocent. I mean, we have not the whole spectrum of leeways to curb climate change, but our consumption behavior overall is responsible for around 60 to 72% of global greenhouse gas emissions. Meaning what we as households do, it's driving, it's heating, it's also the oil companies, they don't produce for nothing, they produce for us, right? So we use it. Of course, we cannot change overnight, but this is used for human consumption, human pleasure and human living, of course. It's not a mean to itself, right? So we have to be aware of the fact. Also, when it comes to global land and water use, material use, we are also responsible for a large fraction of the total one, 50 to 80% actually. And so what we know now is that actual change needs a system level approach, but also an individual level approach. So we cannot only focus on policymakers, for instance. There's also an individual component in that. So what if there are incentive structures that lead households to behave as environmentally friendly as possible? Yeah? Of course, not everything is possible, but some things can be changed. There are a lot of substitutes we can switch to. What if we had a good incentive structure in place that leads us naturally to go for those incentives? On top of other policy changes and technology, of course, which we also will need, because without technology change and progress here, this will also not be feasible. But this is one part of the puzzle social sciences focus on, because we focus on individual human behavior. That's where we have our research focus. So, as I mentioned in the beginning, this is all about behavioral interventions. And what I brought with me today is an example of such an intervention at the University of Innsbruck. I think most of you study here or have been around in those buildings frequently, and you know this picture actually. This is a behavioral intervention, a so-called nudging intervention by the health department, or in this case, the personnel development department. It's a health initiative, and it says, did you know that taking the stairs instead of the elevator decreases your type 2 diabetes risk? So what these nudges or behavioral interventions do is they subtly change your choice architecture, your decision setting, by not forbidding you to take the elevator, by not giving you money to take the stairs, but just giving you some information that might change your mind on the fly when you are in this decision. This is a combination combination of framing and information intervention, right? You frame it in a way, you have a nice image here, you have some information giving, and this combined should change your decision in this setup. This is just one way to do those behavioral interventions, a very subtle one. There are many more, way more complex ones, multifaceted ones, but this is just one example of many, okay? Just to give you some context, what we mean when we talk about behavioral interventions, okay? We don't change economic incentives here, we don't force people, we don't forbid anything, we just change the choice architecture, give some information here and there, and try to also utilize and leverage people's irrationalities. Because we are, as humans, irrational. We have some biases and some thought processes. If tackled right, can change behavior for the good. That's the idea of nudging, actually. Those nudges have been applied thoroughly in the literature to alter, change individual environmental behavior. So the idea is I apply those nudges, and people then would change and behave more environmentally friendly. That's a great idea because it's cost efficient. So these nudges are not very costly, as you have seen. Also, they don't interfere with individuals' freedom rights, so they can change, they can do whatever they want, but they just change the choice architecture in a bit. So this has been done thoroughly. The problem here is that the literature now shows that it's not really effective. When it comes to actual environmental behavior of individuals, so choosing public transport instead of the car, or changing the energy provider to a green one, or eating less red meat or something like that, the evidence is very mixed. Usually the effect sizes are very, very small. So if you apply those nudges, yeah, there is some change, but it's very, very small. Also, you have some backfiring effects occasionally, meaning that you want to make people more green, but you achieve the opposite. People become more brown, actually. Very complex psychological phenomena, but this happens sometimes. And a major problem in the literature is publication bias. And as this is all about meta-science, publication bias, I like to explain it to you like there is academic incentives, meaning every one of us needs to publish. And it's very hard usually to publish findings that are non-statistically significant. And that's a problem, because what then happens is you have some self-selection going on. Only those studies that find an effect are published. The plethora of studies that doesn't find the effect is not published, and this biases the overall picture and the balance of evidence, because you think there is something, but probably 90% of actual studies conducted don't find anything, and this does not surface, and this is an issue. So when you control for that, the effect sizes are extremely small. Okay, and only some types of nudges seem to work consistently. For instance, defaults. I will show you some about that in a minute. So of course, we now know that there are some doubts when it comes to the generalizability and the effectiveness of those nudges on direct environmental behavior. I brought with me nice results that illustrates that from a large study from Della Vigna and Linos 2022. What they did was they did a meta-analysis on those nudging studies, not only in the environment, but overall. And what you can see here on the y-axis, on the left, is the treatment effect. So how strongly did the intervention increase the take-up rate of the environmentally friendly behavior or the health behavior or whatever? And on the x-axis, what you can see here is the control take-up rate. This basically means before any intervention, how many people actually already behaved in the intended manner. Okay? If few people do it, we are more on the left. If a lot of people already do it, we are more on the right. And what you can see here, those dots indicate the effect sizes of those interventions, and it's hundreds of them, what you can see. And it's multiple different domains. And what you see is that there are some substantial effect sizes, right? You have some interventions that increase the behavior by 20 to 30%, which is huge. And you also see some inverse U-shape, where you see that in those studies where the control take-up rate, so the people that they weren't treated, was very low. So those who don't exhibit the intended behavior, nudges don't work. If a lot of them already do it, right, when it's 60% or more, they also don't work strongly. But the sweet spot is in the middle. So when there is a take-up rate of already 30 to 40%, then nudges usually are most effective. So you need a critical mass already being engaged, because if it's normatively not accepted to do certain behavior, it doesn't work. If everybody does it, you have those hardliners that cannot be convinced, it also doesn't work. In the middle, there's the sweet spot. So that looks quite promising, right? But then they redid a study, not looking at academic papers where we have publication bias, as I mentioned before. They looked at so-called nudging units. Nudging units are government-driven units of social scientists that apply such nudges in the field, right? For instance, in Innsbruck, there are some examples of that, to change people's behavior for the better. And they don't have this incentive to publish a significant effect. They just report what they find. And this is the results they have here. What you can see, of course, effect sizes are way smaller. So it's not as promising as before. We have actually a flat line here, not really depending on the control take-up rate, and around 0 to 5% most of the time, which is not a lot. So this is a very small effect size average. Also, what is interesting, it's not only about how those interventions work, but also whether they are adopted or not. When you look at those green dots, those are those interventions that have actually been implemented by policymakers. Do you discern a pattern that those that work better are implemented more frequently? I don't. So what we see is that there is not really an association between the effectiveness and the likelihood of implementation. We have some that work, that are implemented, but some that work really well are not. And also here we see that, for instance, the newsletter example that produced a negative effect was implemented, because there are some other policy incentives of policymakers that could drive the results, right? Probably it was a prestige project of a policymaker. He wanted to do it, he collected the evidence and implemented it. So we as social scientists, of course, have also limited scope of helping if policymakers don't adopt what is evidence-based. So I just wanted to show you here that the evidence on nudging on direct environmental behavior is a bit problematic and not really strong. What we now do is something different. Recent research now focuses on those interventions, but not on direct environmental behavior in an applied form, but more to increase support for those large-scale, efficient and effective climate policies. And one of them would be carbon pricing, putting a price on carbon emissions, internalizing the external costs you cause when you emit carbon, right? Because there is some damage, and we can measure that and quantify that. This would then be priced in the economic transaction to actually align incentives with the actual damage you cause as in your transaction. So why could this be more fruitful? Imagine most people would argue, if I change something on a small scale, this doesn't make a difference. And other people might not change. And then they are free riders, and I don't want that because it's unfair. For those policies, there is no free rider problem because once implemented, everybody has to pay the price. Okay? Those who emit the most pay the highest price. Those who emit the least pay the lowest price. And also, you don't have to change your behavior based on one subtle nudge all of the time for months and years, which can, of course, be hard to do with such a subtle intervention. But if you have economic incentives in place and goods and services are priced differently, the green ones are way more cheaper than the brown ones, then you always have a constant incentive to do so. And studies show that people react to those incentives and change and alter their behavior accordingly. Okay, this is the main focus. So carbon pricing is a very efficient and effective policy. Why it is efficient? Because we price it in the market transactions and we don't forbid people to emit, but only those who have a very high preference to purchase a certain good or produce a certain good do it. All others would say, nah, I would like to, but it's very costly, I switch. So you have a sweet spot of effectiveness and efficiency. That's why carbon pricing is liked by us economists, because we have an efficient market outcome where we don't lose resources, right? Or not a lot, at least, because some deadweight losses are always incurred when you have tax implementation. The problem is that only 25% of global emissions are currently priced. So that's not a lot. Most emissions go underpriced, or they have no price at all, meaning you just emit, you cause damage to others, but there is no price mechanism that captures that. And if there is a price, it's usually well below social cost. Social cost is nothing more than an approximation of what 1 ton of CO2 does in damage to society and the economy. Currently, estimations hover around $120 per ton of CO2 as a lower bound, but they go up to 200, 400, 500, whatever. So it's actually a lower bound. In Austria in 2025, we have a carbon price. The current price will be around 55 euros per ton, so way lower than the actual social cost would be. Okay, so there is the necessity to come up with carbon pricing where there is no price, and also increase carbon prices where there is an insufficiently high carbon price. But there is low acceptability. So people don't like taxes, of course. They don't like carbon prices. They don't like government interventions. So that's also the reason why not a lot of countries have a carbon price. And when they have it, it's way too low. And this jeopardizes the long-term implementation and also the level of the carbon price. And 3 examples I brought with me. In Switzerland, Swiss voters actually rejected in a direct vote a CO2 price, a higher one. So they just said no, they were not willing to accept it. We had some protests in France, Gilets jaunes, the Gelbwesten, who were protesting against implementation of a fuel tax, which was then withdrawn. That means that they didn't implement it, which shows that the government is also depending on the public perception, of course. So they also want to be re-elected. And then we have the green parties in Austria and Germany who lost power in the last elections, of course, changing also the outline, the government program, and the focus for the next years. Okay, so we see that it's very important that people accept this, know why it's important, and are willing to also support it when it comes to voting, especially. So real world support is important. So not only saying I like it, it's good. No, supporting it in the real world. We're being willing to vote for something or argue for something. That is what our project will be all about. There are multiple explanations why people don't like those taxes. Of course, there's tax aversion. People don't like taxes. The label itself is not appealing to us because we lose money, of course. Who wants to pay taxes? Nobody does. Then you have fairness concerns. The argument here goes like, those who have not a lot of money are disproportionately affected, meaning that the tax itself is regressive. Of course, if you rely on those carbon-intensive goods and don't have a lot of money to switch, then you would be forced to pay the carbon tax, which would then harm you, which is actually an issue. Austria implemented the Klimabonus, which is a carbon dividend to circumvent that. Now, all of a sudden, I don't know why, they ditched it. Okay, I know why, because of budget concerns, but this would be a very efficient and very good measure to get rid of this regressive nature of the carbon tax. But all of a sudden, they removed it, which is not good. So there are ways and measures to get along with this and circumvent the problem. Also, people don't know how a carbon tax works. They think carbon tax is just a way to collect money and then you use the money to fund green technologies. Yes, you can do that, but you don't need to. The price difference between green and brown goods is sufficient for people to change. There is a substitution effect. If I quadruple the price of a good versus another, most people will change. They will like it, yes, but it's just so much cheaper to go for the other one, so much more attractive that they are psychologically willing to go for the other project. And this happens on a mass scale and has then a strong effect. So we know that this works from empirical studies, also from experimental studies. So people think you need to use the revenue, and the government collects revenue. It's not clear where it goes. So there's also the problem of distrust in the government. So where does the revenue go? How do they use it? Is it for a general budget? Does it go in some channels, in some dark channels, and so on? So distrust in government is an issue. It's very much correlated with the disapproval of carbon taxes overall. So the bottom line is, yes, it's about efficiency and effectiveness, but the whole issue is very much psychological and political as well. If you look at the United States, there's a war when it comes to climate change, when it comes to taxes. We have those on this side and those on this side, and they clash all the time. So it has a very strong political feature as well. And behavioral science has tried to use those interventions I just described before to increase support for carbon pricing, right? To convince people in different way, shapes or forms to support it. Yeah, by voting or by reaching out to a government representative or whatever. And what has been done is some framing strategies, some persuasive messaging. So try to convince people that it's good, giving some information as well. But the literature is very scarce, meaning that there's limited evidence. We don't have a lot of studies. And if we have them, they're only based on hypothetical scenarios and self-reports. So you do those interventions and then you ask people, do you support carbon pricing? This is not enough because we know that people say one thing and do the other. There is an intention-action gap, a feature that is called cheap talk in social science. People say, yeah, I do it, but actually they don't. And we need evidence for the latter. We need to see whether people would be actually willing to do it because this is very much correlated with voting behavior. Yeah, that's the idea. So the open question we want to answer in this large-scale project is whether these behavior interventions that have been used to induce more pro-environmental behavior directly can impact the willingness to support carbon pricing overall, systematically. And usually what is done is you do a new study, one single study where you test some interventions on a real-world outcome, because this is the novel thing we do here. We don't rely on self-reports. We want to have some proxies on real-world support, not just saying, but doing, which is more correlated with actual relevant behavior. So usually one would do a single study, one single study on a certain population where you try out those nudges on the real-world outcome. But, and now the meta-scientific component comes in. I want to talk a bit about that, where we are much more into meta-science now, also in the social sciences. Those standalone studies, imagine it as follows. You want to look at the effectiveness of those nudges in the United States with hundreds of millions of people. What you do is you draw a sample of 1,000, 2,000 people, apply those nudges and draw conclusions. Everybody of you will be aware of the problem here, right? You have a very small sample of a huge population. You can be lucky and have something that is really representative, not only in terms of demographics, but in terms of behavior and the effectiveness, but probably you have bad luck and you draw a sample that does not really show what the average American would do when they would be confronted with a nudge. So there's some sampling variation. You have a noisy draw in those experiments with a smaller sample from a large population. This is an issue of single studies, and you also have some researcher degrees of freedom. So what we as researchers do is we decide which intervention do we apply, on whom, yeah? So is it the United States, is it the world population, is it Germany, Austria, and also how do we analyze the data? Do we use a regression? Do we use non-parametric tests? There are hundreds of thousands of ways to analyze a data set, and every research team chooses exactly one. And this is an issue. So if you then use meta-analysis, which we of course need because one study is not sufficient for policy guidance, we would aggregate all of those researcher degrees of freedom. So all of those nudging studies we would have in the meta-analysis would differ not only in terms of the intervention, the behavioral intervention applied to the nudge, but they would differ also in analysis, they would differ in the population applied, which makes also the meta-analytical effect very noisy, imprecise, because there's a lot of variation across studies, which is not a good thing. Okay. Also, you have a problem of publication bias. In meta-analysis, you only see what has surfaced, meaning if there is studies that have not been published because they produce null effects, you don't have them in those meta-analysis. So you would overestimate the overall meta effect of those interventions, of course. There are some post hoc ways to come up with a correction econometrically, but of course this is only an approximation. What has not surfaced can never be retrieved fully. You know what I mean? That means that if some interventions structurally lead to backfiring effects or don't work, I can never recover that because they have not been published. This is a huge issue in meta-analysis as well. And also as researchers, we have some path dependence. Every one of you who did research or looked into research of specific researchers, there is usually path dependence. So what they started with is usually where they go next. Of course, there's some changes in one or the other direction, but the next study will be most often quite similar to the last one when it comes to methodology and approach. So this is also a researcher degree of freedom, so to speak. Huh? And also for such an important policy question, we need to come up with a methodology that prevents issues such as p-hacking or harking. What do we mean by that? So who of you doesn't know what p-hacking is actually? You don't know what p-hacking is? So p-hacking basically means you have a study, could be an empirical one or an experimental one, and you don't find an effect. But you know you need to produce an effect in order to publish your study. So what do? You try different econometric specifications, analysis, you try a t-test, you do an OLS regression, you add a control variable here, you trim the data to a certain extent, and then you retest and retest, and then once in one of 100 or 500 specifications, you find a p-value slightly below 5%, your significance threshold. And then you say, wow, nice, I have an effect, you publish it, you change your whole idea because usually pre-registration was not a thing in the last decade or before. So you just also engage in harking. You just change the hypothesis after you know the results. So you say, okay, we expected this ex ante and this is the result. And we need to trim it because, of course, people were too slow in reading the instructions. So they justify the things ex post. And this is a massive problem because you then have publication bias all over the place and have an inflation of effect sizes in the literature, which gives you a false picture of the balance of evidence. This is where meta-science comes in because this is a huge issue. Okay, so now I'm going to show you the methodology we applied to tackle all of those issues because there is a better approach that actually gets rid of all of the drawbacks I just talked about, and it's called many designs approach, which is a rather novel approach, a novel way to answer important research questions, especially because those studies are very expensive. The one we did here costed around $130,000. That's a lot for a study. But for such an important question, it is worth it to also use tax money to answer this in the most comprehensive and robust way possible, actually. So what we did was a new paradigm in the field of environmental economics, a crowd science initiative, where not we, as of course biased researchers, came up with one study. No, we invited 55 international independent research teams, experts from the field, to come up with a randomized controlled trial, each of them with one, okay, independent, use their expertise, their knowledge. They are experts from all around the world. They come up with a study. And all of those 55 studies answer the same research question. Okay, so what is the impact of behavioral interventions on a support for a price of carbon? This is the idea. And the cool thing here is that we apply all of those 55 studies on the same population, so we keep the population constant. Differences across studies cannot be due to differences in population. And we also analyze all the studies in the same way, so we get rid of the degrees of freedom in the analytical space as well. The only difference here is the designs. And this is what we are about. We want to see which design does work and which doesn't. And this way of doing that allows this. We not only let researchers decide which intervention to apply, but also what is an appropriate outcome measure to measure real-world support for carbon pricing. Because who are we as Innsbruck researchers to know how to measure best what captures people's willingness to support carbon pricing in the real world? We also leverage crowd science here. So remember, again, each of those 55 teams comes up with a study, intervention, control group, plus a measure for real-world support. And then we aggregate all of this evidence in a large-scale meta-analysis. I'm really proud to present it today for the third time now, and it's really cool results and interesting ones, and it resonates well with the literature as well. After that, we have some meta-scientific research questions, of course, because we want to know now what is the overall effect. So we want to give meta-scientific implications and meta-scientific evidence to policymakers. So what we do is we aggregate all of those results in a large-scale meta-analysis, where we have a meta effect, where we can say overall nudges work or don't. And we know that immediately. The problem with meta-analysis would be there is nothing. We need to wait for years or decades until enough evidence is here to do a normal meta-analysis. We don't have the time, so we do it now, immediately in 1.5 years, to provide evidence and to fast forward knowledge generation by years or even decades to give policy recommendation. Then we also used a policy survey which was constant across all of those 55 studies. So remember, each study had their own real-world outcome. So we measured each study, of course, only in terms of their outcome. But in order to compare it on a single metric, we also implemented some self-reported measures. So we have both. We have self-reported, but also observed, which is the novelty. And for that, we asked people, okay, do you support carbon pricing in each of those 55 studies to see if the interventions work on self-reports as well. We asked them whether they support a raise in carbon pricing, a support to raise it to social cost, where they support carbon pricing with carbon dividends, like we have in Austria and so on. And then we also wanted to see how large is the variation across those studies. And the variation can only stem from differences in designs because population and analytical choices are fixed. And what we can see then is, okay, do we need to come up with those different interventions, or do they measure basically more or less the same thing? Do they produce the same true effects? If they do, we just can go for one random one and apply them consistently because the others don't work differently. They all produce the same outcome. This is what we can also show here, which is a novelty. So again, as a contribution, we're the first who come up with this crowd science framework, meta science framework in environmental economics, have this collective innovation. So we have crowd knowledge, wisdom of the crowd, of experts from all around the world to come up with their best shot behavioral interventions to increase support. We give meta-scientific evidence to policymakers because one single study is not enough to guide policy. As when I started studying here, I thought, yeah, you have a study and this is the best evidence you can get. But this is not true. There are so many issues with single studies. There are so many incentive issues as well. And we get rid of that because they have to pre-specify all of what they do in advance. So they cannot p-hack anything. They cannot change their hypothesis. They come up with a pre-analysis plan of their study. I will show you that in a minute. And then we analyze it centrally. We don't have an incentive. It's their designs, right? We publish the overall meta-scientific paper. And also very cool, we can isolate the heterogeneity, which can never be done in a normal meta-analysis. And we can come up with very precise meta-analytical measures. This is an advantage as well. So let me now come to the procedure of our project. We started already in 2023, actually. But in May 2024, we launched a project. What we did was we registered a very comprehensive pre-analysis plan where we specified the whole procedure, the selection procedure of the teams, what they have to do, what they have to come up with, how we analyze the data, on which population we're going to do that. Yeah. So everything that is relevant for the public, we registered in advance. So we cannot change our reasoning ex post. We cannot change our analysis. This has been published. As a timestamp, it's online, everybody can retrieve it. And if we change it, we are non-credible. So you can really check that. We prove that this is not flawed. Yeah? Of course, we did some power simulations. I did some analysis here to come up with a good sample size and number of studies to have a very high power. What does this mean? You need a certain likelihood to find a true effect. If you have 5 people, the likelihood is very low that you reliably detect an effect that is in the population. You need a larger sample size. And you can calculate how many people you actually need to detect an effect of a certain magnitude with a certain likelihood. And I did that here, and I can tell you that we are capable of finding a very, very small meta effect. So an overall effect of those interventions, very small, with a likelihood of 90%. So we are very highly powered, meaning that we can uncover the truth, right, if it's there. And we also registered an IRB approval of the University of Innsbruck. So the ethics board went through all those proposals that I'm going to show you some of them afterwards, and said this is ethically okay. We did it for the whole project and for the 55 sub-studies. Then we launched a project website. If you want, you can check it out, where we have all the information for the research teams and for the public. The procedures are outlined there as well, and the teams get regular updates and can also do the tasks on this webpage. Then we had an open call. So how did we get to our research teams? Now, of course, we used some mailing lists of social science disciplines, finance, economics, also psychology. We went on LinkedIn, we went on Twitter, former Twitter now, X, and tried to recruit high caliber research teams. When I mean high caliber, it's not that we chose them, because then we would again decide who comes up with studies, which is again our choice. We don't want that, but we try to have some level of academic quality, of course, here. Yeah, it was possible to have 2 members for each research team, so up to 2 members, and they become co-authors of the paper. That's the incentive for them. It's the reason why they engage in all the work, because they have some good outcome in the end. So we want to publish in Nature or Science. We really aim high here. That's our main focus for the project. And of course, there is some incentive going on. In total, 135 research teams applied for the project. This is a lot. We pre-registered, of course, everything in advance. We had 42 teams because this was based on our budget, because it's very costly, of course, and also on feasibility, because we had to run online experiments. We cannot do lab experiments. On Prolific, which is a survey sampling company, and they have some limitations here as well. So then we randomly selected, we registered that, we randomly selected 42 of those teams from the 135. But then we saw that we have so many teams who are interested, and we thought, okay, why not increasing power and crowd knowledge even more? And then we wrote an addendum, an annex to our pre-analysis plan, registering 25 additional teams. We, of course, randomly drew again from the remaining teams who have not been selected in the first place. Okay. Importantly, we didn't do that before, after we looked at who was selected, because then we could also be biased in our choice to say, no, that's not good research teams. Let's come up with 25 more. No, we didn't do that. We did that before looking at who was actually selected. Okay. So then we had 67 research teams, and of those 67, 55 completed the whole procedure, meaning they went through the whole steps, the entire step process of the project, from the beginning to the end. This is the 55 interventions, 55 studies. We have people from different disciplines. We have people from econ, because we are econ related, so we have some econ mailing lists. So people from there are represented quite well. We have people also from psychology and related fields. And then we have people from business and management, because I'm working at the Department of Banking Finance, and which is part of the Faculty of Business and Management. And then we have some other disciplines that came into our study, from sociology. We have philosophers, we have mathematicians, so computer scientists. We have a very broad spectrum of different fields to gain some crowd knowledge here as well. We have people from all around the world, the usual suspects: Europe, we have the United States, Canada. In Asia, we have China, we have India, we have Australia, we have Israel, we have, all of Europe, basically. So also very much diversified in terms of culture, because culture can also play a role in how to come up with such interventions. There are different approaches. I told you about path dependence, which is also associated with culture, of course. In the next step, all of those teams, those 55 teams who were selected, had to pre-register their design. So they can, of course, not change it and pre-test it and then change afterwards if they don't like the results. No, they had to come up immediately with a pre-registration of their design. So telling us what is their intervention, what is the control group, what do they do, and how they measure the support for carbon pricing in the real world. They had to come up with that ex ante. What we did was, the only thing we checked was where there is a real world outcome, where there's an implication for reality. And I give you some examples now. You can, of course, not observe voting behavior in such a study, which is what we actually aim for. Direct vote for carbon taxes in Switzerland, for instance. But what you can do is you can use some proxies, some instruments. For instance, are people willing to sign a petition that is sent to government representatives that they should implement carbon pricing? Are they willing to write a letter to a government representative? Are they willing to donate to a charity that lobbies for carbon pricing? Are they willing to purchase some emission certificates, which then increases the market price, which also reveals that they are in favor of carbon pricing? So there are many ways to measure this in a real world context, but we didn't want to choose it. We let the teams decide. The only thing we did was verify whether there's a real world implication. Some of them came up with pro-environmental behavior. So they had some carbon offsets, tree planting. This was not sufficient, because this is not support for a widespread price of carbon. This just changes, this is just environmental behavior. I'm willing to offset a certain amount of carbon, but I don't want to interfere with anything else, right? I don't want to have a market price consistently. It's just a one-shot go. This would be long-term real-world action, okay? After that, we also immediately asked the teams, okay, what do you expect your intervention to produce in effect sizes? Is it positive? Is it negative? Is it large? Is it small? Because we wanted to see if researchers are capable of anticipating how their intervention works, whether it works or not. Yeah? So they had to specify a standardized effect size. It's called Cohen's d. Cohen's d is nothing more than the mean difference between intervention and control divided by the pooled standard deviation of both conditions in the outcome. So a standardized measure of effect sizes. We asked them to come up with that. It's usually hovering between minus 0.8 or 1 to plus 1. Negative effect, positive effect. 0.8 to 1 is it's a large one, 0.5 medium, 0.2 a small one. Okay. They came up with that in September 2024. This is, again, an experimental protocol that shows what we did as the principal investigators, as the project coordinators, and what the teams did. So we had the intro in the study, a huge disclaimer where also the participant rights were explained, that all of this is a social science study conducted by the University of Innsbruck. And then we implemented, or the teams implemented, their study. They had a control group, they had an intervention group where they had some nudges, some behavioral stuff that's going on that might induce a change in support. Then they had their outcome measure they chose. And after that, again, we came in and we had our policy survey, which I mentioned before, the self-reported measures of, do you support carbon pricing? Do you support a raise? And so on. To also have that, which is completely consistent across studies. So the policy survey was identical in all 55. So we really can measure the effects of the interventions on the same outcome as well. Not only different ones, which they came up with. And then we had the end debriefing, and then that's it. The teams programmed the software themselves. They could come up with individual tasks or experiments and group experiments as well. So O3 and Qualtrics are two software packages they could use. And they did it on their own, they hosted it on their own, and they were asked to incorporate the policy survey I just mentioned after their study. So they had their thing. Afterwards, the same blueprint we gave them were implemented in all 55 to have comparability as well. After that, we also had a peer survey. What we did here was we randomly allocated 10 designs to each research team, randomly. And they were asked to assess those 10 designs they got in terms of informativeness, quality of answering the research question, the effect size as well, so what they think the effect size will be of the study, and also the category this intervention belongs to. Is it an information intervention? Is it strategic decision making? Do they use AI? Whatever, to come up with a classification as well, and then for us to ex post rationalize what works and what doesn't in our meta-analysis. That was survey B. What you can see here is the team IDs, 55 studies, and the categories of all those studies. So which category of behavioral intervention do those studies belong to? We have four of them. We came up with that based on two things. Survey B, but other teams decided on which category is the study from other teams. And also a pre-registered AI prompt, ChatGPT 4.0, that we used to then finally aggregate the information of the 10 teams based for one design into one of those categories and assign it finally. Some teams argue it's more like that, more of that. The final decision was made by AI. We didn't want to do it. We just registered a script and used AI to do it. This is the final result. We have a lot of information interventions, so giving information about carbon pricing in different variants, videos, audio, direct information, chatbots as well, because chatbots is use of AI. We have it here as well. Then we have behavioral biases and reflective thinking. I told you that those nudges oftentimes leverage behavioral biases. That's the second category, the green one. And then we have some strategic group interactions. What happens here is people play some economic games where carbon pricing is absent in the control and present in the intervention group, and they learn how it works, probably shaping support for the real world as well. Because then you see how the incentive effects are looking like, and then you probably understand how it works and probably are more willing to support it. Let me show you a quick example or some quick examples of this. So I chose one example for each category. For those AI interventions, one of them did the following. You have a 4-minute chatbot interaction with a programmed chatbot that only talks about carbon pricing, gives you most accurate information possible based on demographic information you entered. The control group, of course, didn't do that. They just had an open topic chat with ChatGPT 4.0. So they didn't talk about carbon pricing. So the idea is that the AI can influence you in some way, shape, or form, to give you information, to convince you, and then whether this might also work in terms of support. This was the question here. The outcome they chose was contacting an actual government representative in the United States, because we did all of that in the States. I'll show you why in a minute, or posting a pro-carbon pricing message on their social media. And everything had to be proved. So that's not cheap talk. They had to upload a proof of support. They had to upload a proof of email sent. They had to upload a proof of actual social media sharing. That was very important to us. For biases and reflective thinking, I chose this study here, which is interesting. What they did was they had a writing task to write to a member of a future generation and talk about carbon pricing and climate change and the impact this all might have. And the control group didn't do that. They had some neutral text they read. And the outcome, of course, was the same in control and intervention, because otherwise you cannot causally infer anything. It was a donation to a lobbying organization that advocates for carbon pricing, and expected, of course, higher donations in the intervention. When you write to a future generation, have some feelings of guilt. That was the idea of the research team here, to come up with that. Then we have an info intervention, a video one, where you just get some some in-depth, highly well-animated video information about carbon pricing versus some overarching info on climate change in the control. And the idea was to sign a petition. Plus, there were two measures. They could also combine measures, donation to another organization that lobbies for carbon pricing. Yeah? And then we had strategic decision making. As I mentioned before, what they did was they played economic games, 5 rounds, text, and the control group was untext. And then there was some information giving as well, and they could learn how the texts work. And then the question here, the outcome here was again a donation to a charity that lobbies actively for carbon pricing. And the idea is, I don't donate money to a charity, to an organization that says we want carbon pricing, we influence representatives, if I don't support it. Because this really increases the likelihood marginally that it will be implemented. That's what we want to have here, some real world implication. Okay. Let me get back to this one. And then it was time to collect data. We, of course, did a small soft launch to check whether all the software packages, the 55 ones, actually worked, because it's highly risky with $130,000 to just run it. But everything went fine. And then we started with main data collection. We did it in the United States. Why in the United States? There are many reasons for that. First, we have enough sample size on Prolific, which is a survey sampling company. Second, the United States are one of the most strongest, largest global polluters worldwide. They don't have a federal carbon tax yet, only some states have it. And there is a lot of heterogeneity in attitudes toward carbon taxes. So a very interesting test bed for our study. Of course, constant. So we randomly allocated participants from the survey sampling company to each of those 110 conditions. 55 studies, 2 treatment arms each, randomly, okay? To really have no bias here, randomized control trial. And we had 175 participants per arm, so 350 participants per study, and overall we had around 20,000 participants in the study, 22,000. So a lot of evidence generated. We did it over 6 weeks because you cannot do it in a single day. We had some waves with some batches where we ran this. And then finally in April, we finished data collection and then we started analyzing the data. And we did that uniformly, as I mentioned, to really leverage our design here to the best way possible to not have any differences across designs or studies in terms of analysis. We did the same thing, a plain vanilla OLS regression. Why? Because this is an efficient and an accurate and unbiased way to analyze treatment effects. You don't need fancy methodology here because the causality is guaranteed by design, because the only difference across conditions is the intervention between control. So the only difference influencing your choice in supporting carbon pricing can only be the intervention, because nothing else changes, because it's a causal way to come up with that. So we just use an OLS regression with a treatment dummy, and that's it. Of course, we also use control variables to circumvent some random sample imbalances ex post. The results were consistent. I'll show you that in a minute. But we did the same thing for all those 55 studies. And then we had a beta coefficient 55 times. And then we converted this one into a standardized effect to compare it across studies, because standard deviations might differ, and some of them had a binary outcome and some of them a continuous one. To really have the same metric for all studies, we converted everything in const D. I mentioned this before. And then we had 55 const Ds with confidence intervals, which we calculated as well. And then we could run our meta-analysis to see whether those designs work, whether there is evidence that it works or not. Okay? And now I'm going to be showing you the results in a bit more dynamic fashion. I programmed a web-based version of the results. How we can see it here. Great. We're looking at the actual observed support of all those studies. So what they chose, each study had their own outcome, but also at the most important self-reported one from our policy survey, which is, do you support carbon pricing? Overall, very plain. It's the most plain version you can have. We also have results here on the race of carbon pricing, social carbon pricing, and so on. If we have time, we can look at it, but I think this is the most important and relevant results. Before I go into the results, I want to show you what the teams themselves predicted their own effect size will be, which could be interesting. It's a self-assessed one. You can see here the team IDs coming in from the left side, and you have the green dots indicating the point estimates or the point predictions of those teams. What you see is that those teams are a bit confident that their interventions work. Some of them are a bit very confident that it works. They have very high effect sizes predicted, which is a bit unrealistic, but we're talking here about massive effects out of a subtle nudging intervention, which is not what happens usually. But okay, we trusted them. And you can see the effect estimates are very much similar, no negative ones. No team expected themselves to have a backfiring effect, which of course you should, because otherwise you wouldn't come up with that intervention if you backfire, if you expect it. But then I told you we also asked 10 other designs, or 10 other teams to assess each design. So we have 10 estimates of effect sizes from other teams for any given design. And we did that as well here in the graph, and I show you that with confidence intervals. And you can see whether the other teams agree with what the individual teams for themselves said, and yes, more or less they do. So there is not a lot of pattern. I think it seems to align quite well. Most of the green dots are in the confidence intervals of the blue ones, meaning they are similar, not statistically distinguishable. So the teams, overall, the crowd thinks similar to the actual teams when it comes to their own study assessment. But some of them are crazy. You see them here on the right-hand side. They are, of course, far to the right to peer assessment because they are just overconfident. But more or less, this aligns well. Now, hopefully, the effect should look similar to that. Right? If they are good in predicting, you would see now when the results come in that they align well. What we see is not really. I show you the final results now. This is what we measured. Okay, this is our final results measured with our analysis for all those 55 teams, ordered from the lowest effect size to the highest one. What you can see is that the difference across studies has not been shown in the initial beliefs by teams, but it is, of course, shown in the actual effect sizes. Okay, what you see here on the top is backfiring, meaning that this is not what we want to have. We see that the study leads to the opposite of the intended behavior. So people support current pricing less after being confronted with the intervention. And we have actually two of them. And most studies produce insignificant effects. They are not statistically significantly different from zero, meaning there is nothing, more or less. But some studies seem to work. We have that down here in the bottom. So they produce reasonably large effects, but it's not a lot of studies. So most studies, again, null effects. When we look at the overall meta-scientific evidence, of course, I did it here with tooltips. What you can see is that the overall estimate of the true effect sizes averaged across all studies is Cohen's d 0.06. It's a very, very small effect size. Very, very small. 0.2, remember, is small. 0.06 is extremely small. So there is basically not a lot. And this is very much driven by those outliers in the bottom, and I will show you some problems with that in a minute. We have some between study heterogeneity that can only be due to the design. We have a standard deviation across designs of tau, 0.12, which is a measure of standard deviation of true effect sizes. So how much do the true effect sizes vary in terms of the evidence we have here based on our meta-analysis? It's a small figure, meaning that there is not a lot of heterogeneity. So most of the studies measure something similar. Yeah, there is some difference, but not a lot. So they capture a similar concept, more or less. Okay, this is what we have here. And what you see below the gray shaded area is the 95% prediction interval. This is an econometric metric that can tell us, okay, if we did a new study from the design space we have here, a similar one, what would the expected effect sizes range from with 95% confidence? And we see that we here are well in the negative. So we would actually expect some backfiring effects to repeat itself, yeah, to come about again if we just use those interventions in the future again. Yeah? So not trivial. You cannot throw those interventions onto people and hope for the best. There is some risk involved. Okay, this is an important go-to message. Now let's look to the right-hand side of the graph where we look at stated support, self-reported. Do you support current pricing across all 55? Same outcome, really completely identical. The only difference here is the intervention. Of course, the ordering changes because some teams produce a high effect here, but not there, and so on. But this again ordered from the smallest to the largest effect size. And what we see overall from a meta-scientific perspective is very much similar. We see a very small effect, in this case 0.08, which is extremely small again. Yeah? The study heterogeneity is a bit smaller, makes sense because we have less features than can differ across studies because we fix the outcome, which is the stated question. But this is what we have right here. And now you're probably wondering, okay, which intervention types work better than others? Let's look at those categories. What we see here is let me get rid of this one actually, then it's better to see for you. Okay, what we can see here is again the same categories I showed you before, the 4 ones, and then here colored for each of those results. And actually I cannot discern any pattern here. So at least those classifications don't seem to tell a very comprehensive picture, compelling picture. It seems not to be really much associated with any intervention. It works better or worse. There are some information interventions on top, but again, also some of them produce negative effects, also backfiring. So it's not clear. It doesn't seem to be the category we came up here that explains the results. We'll show you in a second what we then will do to understand the data a bit better. Okay. But now we have the privilege to show the two dimensions, real-world support and stated support. The idea is usually that you have something high here and something low here. That would be cheap talk. You say you support it, but you don't. Okay, this is a problem. We can show it now. There could also be the other way around, that you have high support here, but low support here. How can this be? The reason could be that there is some mechanic effects in your study that makes you incentivize in terms of support for carbon pricing, but not change your mind. Could be a default, for instance. Assume the following. I have an outcome where it says, do you want to donate to a charity that lobbies for carbon pricing? In the control group, there is a slider where you can set the donation amount, and I set it to 0. In the intervention group, I default it to 80% of the maximum amount. There is no change probably in the mindset based on the slider where it's positioned, but people will of course donate more if the slider is already set to 80 than to 0. Yeah, we have seen it in studies. And this is a problem because this does not really change your mind about carbon pricing, just mechanically leads you to support carbon pricing more. But I could change the charity. I could do anything and you would donate more just because the slider was positioned differently. So you have to also look at changes in people's minds, which is captured by stated support. Now I'm going to show you how those two align, how they relate. I connect now all the team's results from the left graph and the right, observed and stated. At best, they would be very similar, but they aren't. The thickest ones describe studies that produce a significant effect in both dimensions. The intermediate ones where at least one dimension was significant, and the grayed out ones, none of them was significant. But you can see here that the intervention that produced the largest effect, this one here, this one, in the observed domain, produced one of the smallest in the stated domain. That means the effect was not mediated through a mindset shift in support. It was a mechanic effect, meaning the strongest study we had in observed support actually didn't change people's minds about carbon pricing. They just produced a higher donation, for instance, or a higher likelihood of petition signing due to incentives in the study that are a bit confounded. So we provide this comprehensive picture that one dimension might not be enough. You have to look at the mechanism, how the study works. And this, of course, didn't work through a change in people's minds, which is an issue. If you get rid of this study because it doesn't measure what it should, the effect is even smaller. It's still significant because we have a lot of studies, but it's extremely small. Overall, I would say the evidence is not convincing that behavioral interventions can increase support based on our study. Yeah? Very small effect, there is some heterogeneity, and not a lot of studies work consistently. And if they do, they have some other drawbacks, as I have shown you here. Okay? This is the main results so far for these two dimensions. Let me get back to the presentation. What I just showed you is the observed meta effect on top, the orange one, and the stated one on top. The blue ones are the same measure, but just with control variables we pre-registered to also control for random sampling imbalances. Yeah? The likelihood that some people are more likely sampled to one group than to another, that could be due to chance. We can control for that ex post. Results are the same. Yeah? They don't change a lot. They are robust. We find the same results also for the other self-reported outcomes. Do you support a price increase? Do you support social carbon pricing, so at least $120 per ton of CO2? Do you support taxes with rebates? Do you support social price plus rebates? But very, very, very small effects. As you see it in the x-axis, we are around 0.05, 0.06. So nothing is above 0.10. And remember, 0.2 is a small effect. So this is all very, very subtle and small. So not really convincing. Yeah? Might also be driven by some overall outliers. So we would not be convinced to recommend those interventions to policymakers to really have a change in people's minds when it comes to carbon pricing support, the real world, and also not stated, by the way. Great. But this is not the end of the journey because we have to understand what happens here. So why do some interventions work and some don't? And we pre-registered additional analysis. We do meta-regressions where we test some moderators. We want to see whether the quality checks by the teams actually can explain which intervention works and which doesn't. So is it that those interventions that were deemed good by the peer survey teams are actually good, yeah, producing strong effects, or is there no association? We will check that. We will also look whether the intervention type, and I did that also graphically, explains something it doesn't. We will do that econometrically as well. And also we want to check whether statistically then if the effect size beliefs explain the actual results, which they don't really do, as you have seen before in the graph. So what we will do now is sensitivity analysis. We will exclude those studies that produce some mechanic effects, for instance, the strongest one in the observed space, and see whether the results hold. And we do this. We go through all the studies and check what they actually did. We check whether there is a causal pathway that goes through mindset shift, and if not, we just exclude it and see what happens. Some exploratory stuff. Yeah, we mark this as exploratory. We don't say it's confirmatory. We just try and see what the data gives us. Right? You can do that as well. If a previous study is done, you can say we just do some exploratory data digging, and if you mark it, it's fine. Yeah, it's not a confirmatory hypothesis. And then we will also go about hierarchical clustering, because there could be some multidimensional factors of those studies influencing the effectiveness. So, for instance, some teams have some senior members; they produce better interventions. Yeah? Some teams come from different disciplines, and they are probably better. The age could be relevant. Yeah? It could be anything. And we try to get every metric of those teams and do a comprehensive clustering approach to get some clusters and combinations of teams and see what works and what doesn't. And to give really policy advice, who should draft those interventions, who is capable of doing so, and what we have to look at. Yeah, this is what we will do now, from now on. Okay, this is actually it. Yeah, I hope I'm in time still. I think it's 1 hour. Go. Let me conclude. We have the first many design study in environmental economics, where we have real-world support, observed support as an outcome metric, which is novel. We do that also in a contrast with stated support. We find robust evidence, but very small effect sizes. So there is something, we are confident, but it's not a lot. Yeah? Effect sizes, also when scaled, will not be large. Of course, if you apply it to millions and millions of people, there will be something, but it's not really that any intervention works. There is some heterogeneity, backfiring is possible. And also, teams seem to be overconfident when it comes to their own effect sizes. Yeah? They seem to be over-optimistic. Okay, thanks so much. I would love to hear your questions and thoughts and input. Thanks.
Okay, thank you very much, Rene Schwaiger. So yeah, for the Q&A, please use the mic, because the online participants couldn't hear you if you ask questions in the audience. So Ingo will go through with the mic, and I will have a look on the...
Ich verstehe es ganz schlecht. Ich verstehe es ganz schlecht, das Mikrofon. Vielleicht kriegen wir es.
Any question?
So, well then, one icebreaker question from my side. So, in the beginning of the presentation, you mentioned that carbon pricing has no free rider effect, but it's not introduced in all countries. So there is some free rider effect, isn't it?
Yes, you're completely right. So if not implemented, there is free riding. So countries free ride by not implementing carbon prices, of course. But if within a country where carbon pricing is implemented, everybody has to pay it. So you cannot get out of it. That's the idea. And if it's about pro-environmental behavior, turning the lights off, going green when it comes to public transport, there is some free riding, because others say, I take the car, you should go by public transport. This might solve the problem, but I don't contribute to problem solving. But if everybody has a carbon price, nobody can opt out. That's the idea why free riding would not be possible.
Yeah, and then congratulations for your design, how you made it. And you said there are many design studies in other domains. Yeah. Which examples are given there? I've never heard about. So that's really impressive, isn't it?
We did at the Department of Banking and Finance. We had one large one that was similar to that one, where I was not part, but colleagues were, where it was about the influence of competition on moral behavior, on morality, market competition. There is a strand of literature showing that market outcomes or markets itself can undermine morality. There are some papers that suggest that. And then the colleagues did a many design study, I guess 40, 45 teams who did the same thing. they came up with a design to measure that, an outcome measure of moral behavior, and some competition setting, market setting. And then they did the same analysis. So that has been done in other domains as well, yeah.
Yeah. And you showed the map of the participants of the study or of the researchers of the study. There's also some bias in because Africa is not in, so, or South America isn't.
You're right. The usual suspects, as I said, so it's biased in a sense, it's the Western world. With China, we have one team from China and India. But of course, the major global polluters at least are there, but those who are most affected by it are not there. And of course, this is an issue. I mean, we could do a study where we explicitly stratify it in a way that we get researchers from every continent. There could also be an extension to do so. Yeah, this is the focus. But what it could be that the researchers there are not doing experimental methods, and probably there are no research there who want to do that, or depends, right? Could be. Yeah.
Yeah. Any other question? Just raise your hand. In the chat, there's some reverberation. If you are close to the lab, maybe it's better to come over there. Yeah, then yeah, so you mentioned that in Switzerland in 2021 there was some questionnaire about carbon pricing rising, and they didn't want to have it rise. Do you think there will be some change in the last few years now because of real, yeah, for example, the landslide just happened in Switzerland or things like that, or floodings in the last 2 years? Do you think it will change if you re-ask the same question some years later?
I'm very unsure about that. I'm a bit pessimistic, to be honest. But when you look at media responses or social media responses, first of all, they try to blame everything else, right? It's never our fault. It's just natural variation, which is partially true. I think what we do wrong as scientists or the media as well is linking all problems we have now to climate change. What people then think is this is a bias, this is a hoax. Because of course, not everything that happens now is causally linked to climate change. But what we know is those things will occur more often due to climate change. And we should be very clear in our messaging. I think science communication is a big thing which we need to improve, also to get people to support it in the future. But I'm a bit pessimistic actually that if we redo the poll, that people would be more willing to support it actually. I've seen too many studies and talked to many people to be optimistic here. But let's hope for the best. Hopefully I'm proved wrong. And let's see. Yeah.
Yeah, and what was also impressive, your method to avoid publication bias, and I think that's the only way to get rid of it, because how to solve the problem otherwise? No participant of the study had to fear to be to fear publication bias, because all will be published.
Yes.
You published all in
yeah.
the list. That's perfect. That's really good.
I mean, as I mentioned, you can correct ex post, but you never fully correct because you don't know what happened. And there are some cool measures to circumvent the publication bias problem now in science, which is not so prominent, but some researchers do. It's registered reports. This basically means you don't submit a paper, but you submit a registered report, which was what we did before, a pre-analysis plan, and you say what you do. I do this and that and that, and analyze it, and you motivate the research question. And the journal says, yes, this is an interesting question to be answered. It's adequately addressed methodologically. We publish it, no matter the results. And then you would get rid of publication bias because there is no incentive to dig into the data and try to come up with something significant. Probably, could be some way. Yeah, pre-registration does prevent at least p-hacking to some degree, because if you pre-specify everything ex ante, the referee says, okay, why did you use this test? You specified this one. Show me this. And this should be the main one. Yeah, but it's not perfect.
So due to your results, it's about 1/3 of the 1/3 is publication bias, because it was in a negative. Nobody said it's negative, but 1/3 was.
Actually, it was. If you look back, let me check that. If you look back to the results, actually, one could expect that most of the studies wouldn't be published. Let me check that again.
At least 1/3.
Yeah, at least.
The negative.
So all of the negative ones, probably because there is some effect. This could be cool to be published, but all of those insignificant ones
also not
could never be shown because
including the insignificant, it would be half of them.
yeah, at least. I mean, that's you see that there is a lot of incentive for publication bias and for yeah.
Sure. Yeah. Any questions? There's some question. I honestly don't know much about carbon pricing. You mentioned that people often don't know what happens with the money collected by carbon taxes. Could you maybe shortly explain what is it used for? I didn't quite understand that from the presentation.
Very good point, actually. Yeah, I mentioned it in the beginning that the tax itself, so this is the first point, would have an effect, irrespective of how it's used, due to the difference in prices, green versus brown goods. But of course, you get a lot of revenue with the carbon tax, and you can use it in various ways. So some countries use it for the general budget. This is not really what people like, because then it's not clear where it goes. Yeah? This is what Austria does now, because Austria formerly had the Klimabonus, carbon dividend. This is one way to use the tax revenue. You collect the tax revenues, you divide the whole tax revenue after cost by all eligible citizens, and you just redistribute it again. And this works because you then counteract the average negative income effect for people via still having the substitution effect, the price incentives. This is what Austria did, which is a very elegant way to do. But now they got rid of it, and what they do now is they use the tax revenue for the general budget, yeah, to really improve it more or less. And where it goes, it's not clear. It goes in the general budget. This is one way. Another way to use the tax revenue is to fund green infrastructure. So you have a double dividend here. You have the incentive effects of the price, plus you use the money to fund green technologies, to fund the transition. Could also be a way to do that. And that's three ways it's usually happening: general budget, carbon dividends, so rebate programs, and investment in infrastructure and green technology. Yeah. But very good question. Thank you so much.
Yeah. Other questions? Yeah. Doesn't look like. So then I would say thank you very much again for your study, for your presentation. Thank you for coming, Nastasia. And yeah, so thank you to all of you. There's one lecture left now. And then after this lecture, please remind to upload your task on the participant folder. If you have any questions, just feel free to contact me. Yeah, so then we see in 2 weeks, I think it's. Yeah, thank you very much.
Thanks so much. Bye-bye.
Bye, thank you.